Physics and Friends. So today we will learn resolution of vectors into its components, x and y components, which is a very important concept, whether you are dealing with projectile motion, whether you are dealing with any kind of mechanics questions. This concept is very much essential to understand. So in order to go further, I would like to draw this four quadrants, these four quadrants, which are known in mathematics. First quadrant, second quadrant, third quadrant, and fourth quadrant. Okay. So for example, if you're moving along x-axis up till 5, okay. So if you're moving along x-axis up till 5, this vector is only along x-axis. There is no value of y. There is no value of this vector on the y-axis, right? So we will write 5, 0 here. There is no value along y, right? Similarly, if we talk about this vector, the yellow one, this has no x component, it has only y component. So we will write 0, 5, right? But it is not the case that your vector always lies along in x or y only. There are some times, or even most of the time, you have the vectors which are in either x or y or both, right? So I'm going to draw another vector. For example, there is a red point and I want to know what is the location of this point in the Cartesian coordinate system. So I will draw another vector which is in blue color. Now for this blue color, I do know that it has two components. One is along x and one is along y. So for this blue vector, the red one is its x component and the yellow one is its y component. Okay. And you need to see that these two components are at 90 degrees to each other. This is very important concept. You need to remember that if a vector lies along in x or y both, then it has to have a two components. One should be along x and one should be along y. And these two components are always perpendicular to each other. Okay. So for example, I'm making these two vectors and I'm making a full square now. So there is something that you need to understand here. For example, you have theta here. So what should be your cos theta? I mean, this is x component and this is y component, right? Similarly, if this is y, this is also y, because you have two triangles, and in two triangles you have two same components which are fx, fx, and two y which are fy, fy. Now, I have told you that these two components are always in 90 degrees. So you can see these two components are at 90 degrees to each other as well. These two components are at 90 degrees to each other as well. Okay. So from here, I would like to say that in order to see what should be our x component and what should be our y component, you need to see where is our theta and where is our 90 degree. For example, this side is having theta and 90 degrees. So this will be your cos theta. Okay. If this is f, this will be f cos theta. If this is n, it will be n cos theta. If it is 12, then it will be 12 cos theta. Okay. And if theta's value is 30 and this value's vector is 12, so you will write 12 cos 30. Okay. So this is how you need to find out the x component. Similarly, if you find out the x component, the other one will definitely be y component. So if this is f, this is 90, this is f cos theta, this is going to be f sine theta. Similarly, if f's value is 12, theta's value is 30, so you need to write 12 sine 30. You understand that? Okay, let's move on to the next. Yeah, one concept more. One concept to be understood here. If you have theta in this direction or in this direction, I mean, this angle and this angle are always equal. Remember that these are all alternate angles, okay? Alternate angles. And if you have theta on the other side, which is this, uh, yeah, this. So I'm not considering this angle or this angle. Now I'm considering this angle. Now for this, my two coordinate, I mean, my two components are one is this and one is this, and this is my actual vector. So this should be 90. Now I have told you that wherever you find theta and 90, it should be now cos. Okay. So this is our now f cos theta, and this is now f sine theta. So it depends where actually your theta is. If finding out the location of theta and finding out the angle 90, that side which has both theta and 90 will be your cos side. Okay. So similarly, this will be your cos theta, and this will be your sine theta. So either you take this one or this one. It's all same. All right. So if it is 12, so you will write 12 cos theta. And if it is 12, you will write 12 sine theta. Okay. So let's move on. We need to see some more things here. For example, okay. So I have made a table here and I'm showing you two forces. One is normal and one is weight. These two forces are always equal and opposite in direction. So we know that according to Newton's third law, if there is one force which is acting upward, there must be another force which is acting downward. So that these two forces cancel out each other and there is no motion along X or along Y. Because there are only two forces acting on the body. One is upward, which is normal force or reaction force of the table surface. Okay, this, and there is a weight of the book. Okay, so these two forces are canceling out each other, and you need to notice that these two vectors are totally vertical. There is no x component of normal force or weight involved here. Okay, so this is something you need to remember for this. Okay, no component here. We have either x component. Okay, both these forces are along y-axis, so there is no x component. But I'm showing you another case. For this case, you can see there is a body in green color. A block is coming down and there is a force in red color acting on it, and it is coming down. Okay, so I know that the normal force is always along the at 90 degree to the surface, right? So if I draw the normal, you see this is 90 degree to the surface. Previously we had table and there was a book on it, so normal was at 90, right? So normal force is always 90 to the surface. So if surface is like tilted, the normal will be tilted too. Okay, so this is 90 degree, right? You need to remember that. Normal force is always at 90 degree to the surface. If surface is like this, the normal force will be like this, so that it makes 90 degree angle. Okay. All right. So this is normal force, and this is a force which is bringing the block down. And what about the weight of the block? The weight must be acting downward. It always acting downward. It does not have any, it never goes like tilted. It always act vertically. Remember that weight always act vertically. Now, what is the point? How did I know what is this? It, it is either n cos theta, either n sine theta, either it is w cos theta, or either it is w sine theta, or either it is something new. So how would I know? So for that, I will go back to the concept that we have just learned, okay, which was this. So in this case, we had a force which is called F, and it was, yeah, this was F cos theta, and that was F sine theta, okay? So for example, I am considering this force as W, for example, as weight. So let's see how we will get it. So I need to see that this should be W sine theta and this should be W cos theta. Now I am moving it into the clockwise direction and I will see how it goes, okay? So it becomes like this. If you see, this weight and this weight are exactly in downward direction. So there are two components. One is this and one is this. And these two should be coming down here, right? So I am now going to rotate it into the clockwise direction. Okay. Yeah, like this. And you see, the weight is now being divided into two components. So one is this, which is W cos theta. Okay. And this is W sine theta. And this is your W and this is your normal force, right? So it means the component which is bringing the block down is actually the X component of weight, which is W cos theta. Okay. And what about this W sine theta? What is this force doing? If you take a look, N is exactly opposite to W cos theta, W sine theta, sorry. So I can draw this W sine theta here as well, right? So W sine theta is actually canceling out normal force. Remember that normal force has no X or Y component. It always perpendicular to the surface of the body, okay? And it is always cancelled with one of the components of weight. Now here, W sine theta is cancelling the normal force, and W cos theta is responsible for bringing the body down, okay? I hope you understand that. Okay. So, this is the summary of what we have learned. We have learned that we can divide the vectors into two components. Here, when a body is moving on on an inclined plane and it is coming down, the normal force is always acting at 90 degrees to the surface. Okay. And here, this weight having two components which are at 90 degree to each other, okay? I have told you that when you divide a vector into two components, the two components are always at 90 degrees. So here, these two components are at 90 degrees. So either you draw this component here or here, it makes no difference, okay? So these two components are at 90 degree to each other, okay? And one component, which is W cos theta, has been balanced with normal force, okay? So W cos theta and N are cancelled out. And the other factor or other component, which is W sine theta, is responsible for bringing the block down, okay? So that was it for today. And I hope you understood the concept of resolution of vectors into its components. And if you have any questions on that, you can contact me on the given number, okay? I will be very happy to help you. Thank you so much. See you in the next video.